Hello.
Hello?
Hey, what's up?
Hey, not much. How about you?
Not much. It's
Awesome.
been shooting.
Yeah. Um, Great. So is this your first time using the platform or have you already tried it a few times?
I've used it a couple of times, so yeah, I'm a little bit familiar with it.
Awesome. So great. Why don't we just jump right into it? So I guess I'll tell you a little bit about myself and then maybe you can share a little bit about yourself.
Sure.
I'm currently working as a software engineer. I've been out of school for about 2 years. Work at one of the big tech companies. How about yourself?
Yeah. I went to a coding boot camp, and I've been working uh about 2.5 years now as a Rails developer. I don't really have much in the way of like a CS background, so that's why I'm kind of going through this platform to kind of practice my algorithm knowledge and like interview questions.
Awesome. Yeah, that's a great idea. I studied CS in college, but I find interviews pretty different from like just taking courses.
Yeah, it's it seems to be way different. It's like a pressure situation and all that, but it's a great like platform for practicing.
Awesome. Great. So, do you have a language of preference?
I guess I'll go with Ruby if that's okay.
Great. That's a great language. Yeah.
All right,
Um,
change it to
okay.
Ruby.
Yep. I'm familiar with Ruby. And I will do they. Yeah. Sweet. So my question for you is um, this right here. So,
Okay.
given a string and a dictionary of words, determine if the string is valid based on all the dictionary words. And I have a couple of test cases for you to start off with. So, here is an example of a test case. Sorry, I usually code in Python, so I will allow you to recode them, or if you want me to, I can recode them in Ruby. But
Sure.
the idea behind it is pretty straightforward. So
Okay.
how do you set I forget the string comment, multi-line string comment for Ruby?
Oh, I think you use a begin and end, but I think yeah, there you go. Begin and
Awesome.
end. Yeah, should work. Okay. All right. So I guess I'll try to give kind of reiterate what I'm uh kind of how I'm interpreting this question. So, but it seems like it's pretty straightforward, at least the wording. So we're given a string and a dictionary of words. We want to determine if the string is valid based on all the dictionary words. Uh, so I basically just read your prompt, but see. So it looks like the first example here: practice makes perfect. Okay, so our dictionary contains practice, perfect makes. That's true. So it looks like every word in the string is contained in the dictionary, which is why it's valid. And for your second example, practice looks like it's missing a word, so that's why it's invalid. Okay, interesting. Um, okay, I guess I'll just start like brainstorming to like kind of tell you what I'm thinking.
Sounds great.
Like maybe it'll go somewhere. Hopefully, it'll go somewhere. But okay. So it looks like the most immediate, I guess, thing that comes to mind. Maybe it's not like the perfect or like not an ideal way of doing it. Is if we could somehow grab the words from the string and then you could iterate through each word and just check if it's in the dictionary. But if you did that, it would be so let me write it out. So you could like so in Ruby it's called like to split the string into the words. So
Hmm.
the string into the words, and for each word, check if it's in the dictionary. It's like I think time wise this wouldn't be as efficient as maybe another way, but time wise this would be let's see. So you have to for each word, say if we have like W words, And I guess we could do like a search through the string, perhaps, or sorry, search through the dictionary. So I think in that case, if we had to sort it and search it, do like n log n if there's like n words in the dictionary. So I think that would be the time complexity in that case. So W
Can you run
words.
through why you think that's why that's the time complexity again?
So I guess for search, the fastest way to sort, it would be n log n time. And then we could do like a binary search through the sorted dictionary, which is the log n time, I believe. But this is given like n words. I guess we have to take into account like how many characters on each word.
Remember, this is by dictionary. It's just a list of strings, so we're not sorting. Yeah.
Okay, gotcha. So I guess like okay, so
it's an array.
Yeah, my thought. Gotcha. I was thinking we could like do like an operation on top of that, but if we don't want to sort it, then I would just do like a linear scan through that. Yeah, linear scan through that. So that would be n times w time, I believe.
That's correct. Yep.
Okay, and then I guess for space complexity, let's see here. So we had to split the words. So we had to put them into their array of words. So that'd be OW space, I believe. Okay. Okay, so I think that would be like a slow approach to do this. But thinking about maybe if there is a faster way of doing this. I don't imagine it'll be much faster, but maybe we can think about if there is a faster way of doing this. Maybe like, because you have to iterate through the words no matter what. I think. Maybe if we, I guess like another way would be if we, once we've stored the words, or once we split the words, we can store them into like a hash, and then we iterate through the dictionary. Oh no, that's not right. That doesn't make any sense. That wouldn't work. Or what if I guess we can store a dictionary in the hash, so for a constant lookup or like approximately constant lookup. Let me think. Store dictionary words in a hash and iterate through the input words or whatever, and like return false if there's a word that's not if word's not in the dictionary. And in this case, I think this would be store dictionary words in a hash would be, so we have like n words. This would be in time, worst case, and then here just be w time. So these aren't they're not nested operations. So I think we're running in like sequence. So I think this would be, let me see, like I guess n time, depending on if n or w is greater. I'm not sure if this is the right analysis for this.
No, that sounds correct. Yeah.
Okay. And then I guess like for space, then that would be let's think here. Yeah, we have to do it like that because the OW space, because we still got to split the words and store them in a hash. Okay. Trying to think if there's like a.
You're also storing the dictionary in a hash, right? So that would be increase your space complexity.
Oh, yes, absolutely.
Yeah.
So I guess O of n space if n is greater than W.
Yeah. I would. Both of those answers are correct. I was just saying, like, if you're being, because you're being very thorough, which is really cool. So I was just like, okay, if you can do that. But anyway, that's besides the point. I think you have two good strategies. It's up to you which one you want to code up.
Okay, sure. I guess I'll. Seems like the second one might be faster, so I'll try this one.
Cool.
All right. Let's see. Get rid of this guy here. So, okay. Let's call this valid sentence in a string in a dictionary. All right. We're just basically following like the steps here. Yeah. Okay. All right. So, let's see. Store dictionary words in a hash. This we call it dictionary hash, I guess. Dictionary. Oh boy. I'm doing this. Doing this right. Dictionary word. Hash. Word is says might as well say true. Get rid of this guy. True. Whoa. Oh boy. Oh, there we go. All right. There we go. Okay, so storing the words in the hash, and then so we got for the input string, we want to Ruby can split it across. It gives you a very convenient method to split it on the word or across on the white space. Yeah, so that gives you an array of words, a words array, and okay, so for each. So now we check each word array, make sure it's in the dictionary. That each new word basically is returned false if it's not in the dictionary. Dictionary hash. Okay, return false if not. All right. Then finally return true if it is. Okay. And like usually what I would do is like probably try to write like a test case. So maybe like usually use like a put statement to assert if it's true. And you gave me some examples. I'm going to try these. Oops. Okay. Whoop. And okay, dictionary. Oh yeah, nice. Use the puts instead. Right. Right. Lowercase, I think. Student, be safe.
Yeah, this looks
go
good.
ahead and, all right, I'm gonna go ahead and run this then just to see if it is. Okay, so first one. Okay, just forgot the lowercase everything. So I guess like, can we assume that the dictionary is all lowercase words or?
Yes, you can.
Okay, so if we were to assume that, then we just had to check for lowercase words. So, so for the, let me see where words array, just check the lowercase. I think we'll check check the REPL. Forgot how to lowercase. I think it's downcase. Okay, there we go. I'm going downcase this guy. Again. Whoa. There. This makes perfect. Interesting. If it's not in there, put that downcase. Okay, so do a little debugging, I suppose.
It's yeah. I'm just gonna save you some time. It's the punctuation.
Oh shoot. Okay. Oh, thanks.
Yeah.
That was taking me a while to get that, I think. Okay. So for punctuation, interesting. So that means if we're splitting across the white space, then that's not going to catch the punctuation. Interesting. So, excuse me, sorry. Can we assume that it's let me see. Like, can we assume there's not any apostrophes or anything like funky like that, or just like just
let's
kind of
say that the only punctuation is a period. Sorry, go ahead.
Okay, sure. So assuming that, and I'm assuming like every language or like in English language, periods end the sentence, then I guess we can. Well, then I'm confused why this dictionary hash didn't store the perfect with the period. But we don't want
right.
that.
So your sentence will contain a period, but your dictionary will just contain a word, right?
Oh yeah, you're right. Yes, because we didn't split it, or we didn't store the period with the word. Yes. Okay. So I guess like this, the simplest way would be to kind of take the string up to the period, or up to before the period. I think that should work. Maybe we can, yeah. Okay, so let me see here. So string 0 to, we take it up to string dot length -2, I believe. That should work. Okay, yeah, that takes us to the second to last element. Okay. I think that should work. Okay. I think that works.
Awesome.
Maybe there's some, yeah, maybe I'll say maybe there's some edge cases that that this doesn't really quite catch.
No, I think it looks good. It's clean. Looks good.
Okay, cool.
Awesome.
Cool.
Yeah, so you pretty much solved this part of the problem. Is there anything? So there's a second part to the problem, just to let you know, but we'll talk a little bit about this the current iteration of this problem. So, can you walk me through what you might think would happen if, say, you had a really massive dictionary, like you had all the, like, I don't know, the English language probably contains millions of words, right? So,
yeah.
Just walk me through what you think might happen if your sentence is really small and then your dictionary is really big in your program right now.
Sure. So, like, given how it's currently implemented, so I guess my immediate thought is it a problem that we're storing every word into like a hash? Like, are we going to run out of space? I suppose. That I guess that could be a problem. Not. I guess, like, if there are a lot of words in the dictionary and it runs out of, and it's like greater than the amount of memory we have, then that could be that we run out of space for the dictionary. Also, let me see. So I'm actually not 100% sure how like a hash lookup works. I know it's like I think on average time it's like constant lookup. And if I'm not mistaken, maybe if it's like there's a lot of elements in the hash, then I think it could perform worse. I'm not 100% sure, but I think I might have that's something I might have like read somewhere. And I guess if that were the case, then this would be not ideal, because then you don't want to look through. Yeah, because you have a lot of words in your dictionary hash, so like that wouldn't be so ideal.
Okay.
Yeah. Trying to think what else.
It's cool if that's it. That sounds pretty good to me. Yeah. So actually, it wouldn't matter. This was kind of a trick question because there isn't much scaling involved in this problem. But you're right. So hash tables have an O of 1 access time, search time, not access time. So if you search for an element, it's going to be, on average, depending on your hash method, it's going to be O of 1. But in this case, you could have, there are only 1 million words in the English language. There's a finite amount, right? So you're never gonna, as long as you know the dictionary, the world's largest dictionary, you can sort of provision the amount of memory you need, right? So it'll never keep growing or things like that. Cool.
Gotcha. So it wouldn't scale in that sense. I see.
It would be fine, actually. Your program would run great. All you need to know is that the size of your dictionary, you'd just be constrained by the amount of words in your dictionary, right?
Gotcha. Yeah.
Cool.
Gotcha.
Yeah, that was kind of a trick question. It wasn't. It wasn't.
No,
it wasn't to confuse anything. I just wanted to get the conversation going in that direction. So the next part of my question is, if you go back to line 24, say we have a sentence like this. Now, oops, sorry. The same sentence with punctuation and spaces removed and all lowercase, and you have your dictionary. And I want you to find out if the words in the sentence, sorry, we'll remove the period. If this string returns true because there are words in that string that belong in the dictionary. So as a counterexample, this would be false. Does that make sense?
Yeah. Oh, so this would also be true then in this case.
Oh, sorry. Yeah, I should change this.
Yeah. False. Okay, gotcha. Just checking.
The idea is there's the words practice makes perfect, and there's an extra X, which is not in the dictionary.
Mm-hmm. Okay, gotcha. So it seems like so all the words try to, I guess, verbalize out loud like how to describe what's going on. So it looks like all the words that are in the dictionary, I guess taken together, I guess you can say like the length of all those words is equal to the original string length. That makes sense. I'm thinking like just gonna add on to your example here.
Mm-hmm.
Practice where like that. This would also be false.
Yep. But
okay.
This would be, but if you were to take that same example and remove the X, then that would be correct, right? Makes perfect.
Yeah.
Practice, yeah.
Gotcha. So it's like any combination of the words in the dictionary.
Yeah.
Okay. Gotcha. Okay, so I guess like just thinking if we were like walking along the string, so like we walk along the string character by character, and then we reach, like we kind of hit a substring that's in the dictionary, and then we could say, okay, that word's up to that point, it's good to go, and then we kind of keep on walking along the string, hit another word, but then we hit like X. Interesting. So, what if this were like A or something? So I made an XP just to make it more complicated. So makes is in, but then we walk to perfect. We see perfect is good, and then we keep walking. We see XP, which is good, but then we have like, and then the rest of it is not makes perfect. Actually, might I ask, like in this case, would this also return false? This example?
Yes, it would, because there is no either your program would capture XP, in which case, you have like RACTICE, which is not a word in your dictionary, or you have practice and you have an extra X, which is not in your dictionary either.
Okay.
But if you were to put like another P here, then it would pass.
That'd be good. Okay, I see. Interesting. So it's kind of like, in my mind, I'm kind of thinking like, all right, where should you where should you make a word, like to check if it's like a valid. Like an example we have here is like we're not, like, how can we track that, whether to check X, P, or like practice, Yep. How do we do that? Interesting. Maybe we could just look at like that P and practice. How would we kind of determine which word to look at in that case? Okay. So, trying to think if there's like maybe like a really like slow way, or like, I guess, not naive way of doing it.
Yep. I think it might be simpler to start with line 26, where, say, you only look for the true case.
Sure. Okay, so for this example, what would be so I guess we would have to check all the well, that wouldn't be so good. But I guess like in this case, we already know that's already 3 words, so we could check like say we did know that there were 3 words in this string, then we could do like a triple nested loop and then kind of just look at all the substrings, and just basically return true if any of those arrangements fits our criteria. Like I said, that'd be like a slow way of doing it.
Okay.
Like triple nested loop. And I guess like if you didn't know the number of valid words in the string, you could check from, let's see. Oh, you could do from that makes sense. Interesting. See, that might not be. I think that's not a good approach because we don't know how many words are in the valid words are in the string. Yeah, I guess like the part that I'm kind of stuck on is what range of the string to look at to determine if it's like a word. If that makes any sense. I guess like going back to the example on line 42 is like, do I look at XP or do I start another word at P and look for the rest of it? So that's kind of like what I feel like I'm stuck on. Oh, can you still hear me?
Yep.
Okay, sorry. My internet's a little slow. Just double checking.
Here's I think this would be a good way to start it if you want to roll with it. How when
Okay.
you're trying to solve this problem, like as a human being, as a human, how do you try to solve this problem?
As a human being, I suppose you look through the string, basically look from the beginning, and as soon as you see a word, like okay, that you look at like practice, and then it's in the dictionary, and then you look at makes, see it's in the dictionary, and then you look at perfect, see in the dictionary, and then X is not. Yeah, so basically just iterate through the word and kind of look at each substring. And similarly for line 38, like makes is in the dictionary perfect, and then XP, and then practice, or you can look at
Right.
X. Okay.
So you're as you look for words, you're going character by character, and you're like eliminating. So for example, in line 26, you're going PRACTICE. You find your word, and then you don't look past again, right? You just keep going. Right? You don't look back again.
So as soon as you, so it looks like as soon as you see a word, then you don't even like anything before that. You don't even worry about that anymore. It's
exactly.
like you only worry about the rest of the string. Okay. So so I guess in the case that, like, what if we see like the iffy example? Let me write down the first part here. So iterate through string. This string. Let's see substring. It's like I to J in the dictionary. I guess keep looking forward, for lack of a better term. So I guess like, yeah. So for the example, we have like, here, try refreshing. Oh, there we go. Okay, so if we were like X here, then okay.
So are you familiar with dynamic programming? Have you heard of that term?
Kind of. From what I like know of it, it's essentially like store data that you've already seen, kind of, and then kind of, so just kind of caching it and then pulling it out later if you see it again.
Well, the reason why I mentioned that is one of the common ways of solving these kind of problems, where you were mentioning you are looking at a string, then you're looking at the rest of it, and then you're segmenting it and you're looking at the rest of it. A table comes in real handy when you do that, right? So if you're looking at each character and you're saying like, from the beginning of this string till to this point, I don't have a word. Just, keep track of, so for example, I've highlighted practice. That's a word, right? So if you were to store it in a table, each character, you'd probably store it as like, here's a sequence of characters, and it's only valid when, this particular string of characters is in the dictionary. So I don't know if that helps in any way, but it could be a potential direction to go in.
I'm a little confused by what you mean by storing it in like a table, like as you're iterating through the string.
By table, we can. Since this is just a string, imagine it as a single table. So in the beginning, you have so you have P as your first character. Does that make a word? No. Then you have PR. Does that make a word? No. And then A, no. And then C, no. And then T, and then I, and then C. And then when you hit E, you encounter a word, right? So in that case, as you can see, every character up till this point is false. And then as you keep going, you can keep going. So once you hit a value of true, you can say that for everything until the previous false, that's a word, right? That's a valid word. And like we were mentioning, you can then segment it, right? So now that you found a word, all you're considering now is, so your sentence then shrinks down into this. And you just do the same strategy. So you take a look at M, then you take a look at A, then you take a look at K, and you take a look at E, and then you take a look at S. And each time you're checking whether this substring is inside of your dictionary. And each time you'll either get a true or false, and then you'll get like a similar table until you hit true. Does that make sense?
I guess the approach I understand. I'm just trying to figure out how we could use that to I guess like solve the issue. So I'm trying to put that together in my head.
Yeah.
Okay. So like we're iterating through each character, and basically keeping track of if that substring is in the dictionary, and then and once we have one, then we input true. But I guess, okay, maybe. Yeah, okay. Maybe I'll try to kind of mimic you here, and then so we see practice, and then so for makes it would be up to here. Makes. Then if I could alter this a little bit with the X perfect happen in this case.
If you want, you can do that. May not be important to solve for the null case, but you should if you feel you want to go through that, that's a pretty good idea too.
Yeah, I guess I'm just okay. Trying to piece things together here. XP.
So yeah, why don't we do that? So imagine your next word is X, right? So say XP is your word even. What would happen? How would that table look like? Or, tell me what the next part is. So you've successfully segmented up to this part. So your string now looks like this, right?
Yeah, so we see XP, so we see X be false, and then we see the P be true, if I'm understanding you correctly.
Mm-hmm.
Look like
Yep.
that. And then I'll look at the rest of it is just all falses here.
Basically.
Yep. And that points to that substring.
Yeah.
So
in the
it
end,
looks like
so in the end, your program would return false, right?
Yeah. Trying to think if I'm overcomplicating this in my mind. This for X. There were X perfect. Yeah, sorry, man. I don't know if I'm like overcomplicating this or.
Yeah, don't worry about it. Do you want some more time to think about it, or do you want to talk about the solution maybe, or it's up to you?
I guess. Give me like one more minute if that's okay. Just
yeah, absolutely. Take your time.
I'll think about it. Yeah, appreciate it. Oh, if I could, sorry, if I could ask, like, I guess like in this example here, because you see the X perfect, I guess from the last up to here, it is a word, but I guess if we were to kind of iterate through and we see XP, and then that's like, so that return, that's a word in the dictionary, but then we checked the rest of it, which is not. So I'm thinking like, how do we like account for that case?
Yeah, that's a good question.
Like if that were to like come up, or if that's even a possibility of that happening.
Mm-hmm.
So it looks like it's
what do you think would happen here? Not that it makes any difference. I know we're going a bit into a rabbit hole, but I'm just kind of curious.
Yeah, that's what I'm trying to figure out. Let's see, so if we XP is true, and then the rest of it is not. We take perfect out. Yeah, I'm not sure. I don't want to like take up too much of your time, but I guess like yeah, I would ask for another hint at this stage.
Okay, yeah. Do you want to? It's up to you, but do you want to walk through the solution, or do you want to try this on your own? Maybe, I don't know. It's up to you. I'd be happy to share what I was sort of looking for.
Sure. Yeah, that sounds good.
Okay. Okay. So yeah. So the main concept behind this particular problem is the use of I think like the easiest way to solve this problem is by using a form of dynamic programming, and it's exactly the way you see it in the solution that we have. So in this case, you would just construct a really long table of all of these things together. Imagine that, and then that, and then that. Sorry, I'm just gonna keep doing that. And then so are we including X perfect in this example? Why don't we include X perfect in this example, just so it's interesting. So sure. Up till here is practice, up to here is makes, this is XP, and then XPERF, PERFECT. Right? So so the idea behind it is you're doing backtracking almost. So you're taking a look at all the characters from, like, as you're iterating through the array, you're going to be looking at all the characters from, say, as you're going through I, you're going to be looking at from J to I minus I plus 1. And J is going to be counting down from I. So if I is equal to, maybe this is a bit too long, but like, how many characters does this have?
Sorry, I made it so complicated.
No. It's definitely not a complex solution. So I'm gonna switch into Python a bit just because I'm more familiar with the syntax here. Okay. So let's go through the solution. So we're gonna call it valid sentence, and we're given a string, and we're given a dictionary, right? So just like we were doing it before, I'm just going to go through the very right here, and we're just going to pass it, and this is our dictionary, this is our, right? And we want to, just gonna move this. Cool. So the first thing that we want to do is initialize some kind of a table, right? And the first thing what we want to do is, if it's an empty string, for example, it'll be vacuously true because empty strings are true by nature. Mm-hmm. Then what we want to do is we want to go through the string. So for I in range of length of string, we want to keep iterating. And as we keep iterating, the default character, so as soon as you add a new character, as soon as you're examining a new character, you're going to append a false value to your table. Just because right now your program has no idea whether it's true or false. Then what you're going to do is iterate from anything from I. So you're taking a look at all characters from I and then backwards. So say you've gone 10 characters ahead, you want to look 10 characters back, right? So you're going to keep incrementing in the range of that. And basically what you're trying to check is if the table at that character, remember you have an extra value in your table, so you're going to need to increment, J. So if the table at that value, I guess, why don't we make it a little bit simpler for this particular example? We'll just do like made, or I, what's a short sentence? I am good, something like that. Nice. And your characters will be I am, and then good. So what you're doing is you're checking if that current value is correct, and you're also checking if the string is from where you're at to I plus 1 is in the dictionary. So this part, let's unpack this a little bit. So over here, you're going to take a look at your first character, right? And then I is equal to 0, and then your table value is also equal to 0, and your string goes from 0 to 1, right?
Yeah.
So it's just 0. And it checks if the table at J, so table at J is false. Table at J is true, right? Table at, currently it's, so let's just look at for I. It'll be I is, your initial value, your table looks like this, true, and then you just added a false, so it looks like this, because you're considering the current character. And then it says, okay, table at value 0 is true, and the string that I'm constructing is the string from 0 to 1, which is just string at 0, right? Which is just the character I. And we're checking if that character is in the dictionary. And if it is, what we're going to do is we're going to set the table at J equals to true. And we're going to break out of this loop. Is that starting to sorry, not J, I plus 1.
So kind of, yeah, kind of, not like explicitly clear, but
and just to get make our program run, we're looking at, like you mentioned, we can go through the whole thing and just get correct words, but if that last string is wrong, the whole thing is wrong. So we're just going to look for the very last table character len of string.
Interesting.
And it's correct.
Nice.
So let's, if you want, we can unpack it a bit. So you're probably wondering about j and the I+1. Because that's where
that's my main that's my main confusion, I think. The j and I, like the iterating backwards or
Yeah. So in this case, you understand that we are going to continuously go backwards, right? J will go from the value I all the way back to the end of the string. Okay. For each iteration. And just quickly, just knowing that there are two loops, what do you think the runtime of this program would be?
Sorry, another thing is when you say from J, so you're iterating backwards.
You're
not iterating just, 0 to I.
Python code to go backwards.
Oh, okay, gotcha. Okay. I thought you were saying. My impression was it was going forwards, so I was a little confused. But okay.
Yeah. So why don't we walk through this I am good example? So I obviously we solve for that, and then say for example you're at m, so I is equal to 0, 1, 2, right? At the character m, then j is equal to 2, right? And it goes all the way back to 0.
Okay.
And every single time you're going to be checking the value at j. So in the very first initial value, since you're appending false every time, your so I A M is currently false. So 0, 1, 2. What did I do wrong here? So find range of j is equal to 0. So we add true, then we add false for A, and then as when we do, so I, and then it goes true, and then the next one, so
we're
I
looking at j is equal to 2, right?
Pardon?
We're at j is equal to 2 at this point.
Yeah, I'm just backtracking a bit to the construction of the table is a little bit off. So in the first case, it's going to be I, so it's going to be true. And then since table at 0 is equal to table at j is equal to 0, and then string from 0 is 1. So we just do table at I plus 1. So now we do, that's true. Do you see, because of this property? So we do the next value of I becomes true.
Okay. I think.
So imagine the first character as just if you're familiar with like bits, like imagine like -1, right? The negative doesn't mean anything. It could be, say you just represent it as negative or positive, and then you actually start your value at like 1, right? So imagine you're storing that all. So your first bit is basically just like a parity bit. Like you would just check if it's 1, it's false or whatever. Just ignore the first character. It's for like vacuous conditions. So actually, the character I is actually I plus 1 is the first character that tells you whether, the first character in your string is a word.
Oh, okay.
Does that sound good?
Yeah, still a little iffy. I apologize. I think I'd have to
don't worry.
Walk through this.
Let's look at it from this. So imagine this is just outside now. So now that makes sense, right? So the first letter I is in the dictionary. Then we look at A. So now I is equal to 1, and j goes from I to 0. So
Yeah.
the table at j, which is 1, is, so in this case, everything's incremented by 1 because of that vacuous condition. So just imagine this j minus 1, if that makes it easier. But yeah, in this case, let's do j minus 1.
Okay.
So it looks behind it and it says, okay, that's true, right?
Mm-hmm.
And
because
then
it was that I.
Pardon?
So at that point, it's table at 0, which is it points to the I.
That's correct.
I character. Okay.
Yeah. And shit. Now this is gonna be confusing if I yeah, never mind. Let's just do that. Okay. We're looking at the A right now, right?
Mm-hmm.
So yeah. So now it's false, right?
Mm-hmm.
So it's table at j is equal to 1, so the value at 1 is false, and we check if 0 and then 1. Yeah, well, I get confused. Yeah, so we check the value for 1, and then we also check from 1 till the end. So the first thing that we do is 0, 1 to the end. So the last two characters are IA, right? In this case, table at 1 is equal to true, and table at string from 1 to 0 is IA,
mm-hmm.
which is false. Good?
Yeah, I think so.
So even if we were to go back to our example, like j minus 1, this still works. So if we're considering the table. So so j minus 1 is 0, it's true, and then the string is from, j to the end of the string, I plus 1. So, 2.
I think I'm starting to see. Yeah, I think I would have to like. I probably have to like walk through like each. I probably have to like put some print statements and like walk through each step.
Yeah, this is just one of the ways to solve it. You can actually use multiple loops to solve it, although that is that's not a, like, I don't think that's like accepted too much usually.
Yeah.
But yeah.
But I guess like earlier you asked like. Yeah, I was gonna say like I think earlier you asked like the time complexity. It looks like since it's nested, it'd just be n squared if I'm not mistaken.
That's right. Yeah.
Yeah. So this looks like a lot cleaner than like like multiple nested loops.
Yeah. And what would be the space complexity for this?
In this case, looks like we're creating. So for the table, that's where all our added space is coming from. So I believe it's like and S is the length of the string. Then I think O of S space complexity.
Yeah, that's right.
In this case, yeah.
Let's just I just want to go through that the XP because I'm actually curious myself.
Okay.
Did you have the X perfect? Yeah, there we go.
Yeah.
So I think ideally your program should return true because it is a valid string.
Yeah.
Because it exists in the dictionary. So yeah, there you go. Sweet. Cool.
Awesome.
Sounds good. All right.
Sweet. Yeah, I think I would have to. Thank you for trying to explain that. I think I just need to like go through it like kind of myself and
Yeah.
kind of try
For
to
sure. Yeah.
envision what's happening there.
Cool. Yeah. You'll.
Yeah.
This is a question
Copy.
I was asked at Facebook. So just something.
Oh, weird. Is that where you're working right now?
No, I'm not working at Facebook, but it was an interview problem there.
Oh.
So
is
usually
that where you're working right now?
Pardon?
I was asking, is that where you're working right now?
No, I'm not currently working there.
Oh, okay.
I did interview there though, so you'll find a lot of companies will do two-part questions. So the first part is a warm-up that sort of gets you into the flow of the question, and the second part is actually the meat of the problem.
Yeah. Yeah, I felt good
Cool.
about the first part was just like an easy like warm up, but yeah, I think like I'm kind of curious like from your like when you were preparing, like what was your kind of like method for like preparing for these kinds of questions?
Yeah. So what I did was I think so I had like my notes from college for the basic data structures and stuff. So I'd probably recommend first thing, if you aren't familiar with those, just make sure you familiarize yourself with the different data structures and algorithms. So you don't need to remember too many, but like it helps. It's good to remember like binary search trees, linked lists. You can look at heaps or hash tables, but definitely cover the basic implementation of data structures. Go through the implementation of algorithms, and then unfortunately just grind through LeetCode is what I kind of recommend. Yeah.
How many questions do you like? I don't without like I don't want to be too specific here, but like I'm kind of curious like how many would you like recommend in terms of like a number of like LeetCode? Because I've heard anywhere from like 100 to like a couple hundred. I mean, I guess it depends on each person, but
yeah, I think
I guess like in your case.
In my case, I did about like 70 or 80, and then I was like interviewing at the time as well, so maybe that counts as more or something because I was doing interviews at the same time as doing the questions. But I think like if you do about 100 questions, you should be okay if you're doing it properly. Like you're actually spending half an hour to 45 minutes trying to solve the question, and then you're not just looking at the solution sort of thing, because that doesn't really help.
Yeah. Cool.
Yeah.
Yeah. I'm like 15 through. I went through cracking the code interview. But it wasn't like an ideal like, actually write it out, implement it. So that's good that LeetCode kind of forces you to write everything out. Okay, cool. Yeah, I think I went way over time. Mm-hmm.
No, don't worry about it. This question is actually from LeetCode. So there you go. I highly recommend LeetCode.
Gotcha. Yeah. No doubt. That's an easy interface too to run your code.
Sweet. So if you don't have any more questions, I think we'll call it.
All right, cool. Yeah, thanks, man. I think we went over time, but I appreciate your help. It was very helpful, and your patience too.
Thanks a lot, man. I'm always trying to improve as an interviewer as well. So thanks. If you have any feedback, just let me know. Thanks. Good luck.
Yeah, for sure. All right. Take care. Bye.
Bye.